Multiplying and dividing rational expressions. Okay, let's start with something simple, basically two fractions, but fractions are also just rational expressions. So what if we had 5/8 times 4/15? Well, let me show you formally and then sort of more informally. So I could write this as 5 times 4 over 8 times 15, 5 and 4. I'm going to factor the 8 now, 2 times 4, and I'm going to factor the 15, 3 times 5, and I'm going to cross off factors top and bottom, so canceling. 5 goes into 5, 4 goes into 4. Up top I have a 1, and on the bottom 2 times 3 is 6. Answer is 1/6. Since there's no variables in this, there are no non-permissible values. That will certainly come in. Now, how would I do this in real life? I would say, well, I can cancel anything on the top with anything on the bottom. So 4 goes into 8 twice. 5 goes into 15 3 times, leaving me with 1 on the top and 2 times 3, or 6, on the bottom. Okay, so generally we keep in mind that this is what's happening, but it's not what we do. Okay, this is what we do. Okay, let's try another one. Let's throw some variables in here. So sort of the same idea. We're going to have a couple of terms. And I'm going to go 5x squared y cubed over 3xy times 9x cubed y cubed over 20x squared y. Okay, so the first thing is we recognize there are non-permissible values here, right? And that is simply that x cannot equal 0 and y cannot equal 0. Okay, those are the NPVs. If x were to be 0, this expression would evaluate to 0. You'd be dividing by 0. Same thing with y. All right, again, let's try this the two ways. So I'll just write the two terms together with brackets. This is what's happening since it's being multiplied. I'll write it as a single rational expression. And now we can start canceling if there is anything. I'm not really going to write this as a factored form. I'm going to say 3 goes into 3 once and into 9 3 times. Write a little 3 up there. 5 goes into itself once and into 20 4 times. On the bottom we have an x and an x squared. Together those make x cubed. So I can cancel those off and take out this x cubed. And on the bottom we have y, and y is y squared. So I'm going to take those two out. Cancel this y cubed divided by y squared is y. And what we're left with is x squared. What do we have up top? We got numbers. We have a 3. We have an x squared, a y, and a y cubed, giving us 3. X squared y to the 4th. And on the bottom, everything, there really should be 1s there. Everything has canceled out, leaving me with a 4 on the bottom. So final answer, 3x squared y to the 4th over 4. Now, this same procedure could have been done just on this expression here, right? So without having to rewrite it like this, we could simply have canceled anything on the top with anything on the bottom. So that's a 3, 5, there's your 4. We could cancel this x with this x squared, leaving an x, this y with this y cubed, leaving a y squared. I'm just going to make that look like a squared. The x squared with the x cubed, leaving an x, and the y with the y cubed, leaving a y squared. And now we have 1 times 3, so I'm looking for my numbers first. 3x squared y to the fourth, and in the denominator 4. Okay, and still with the proviso, of course, right, that neither x nor y can be 0. Okay, let's move on to an expression that's a little more complicated. It's going to involve us doing some factoring. Okay, to do this multiplication, or really what we're doing is simplifying. We know there's 3 steps to simplifying. The first step is to factor all expressions. So what I'm going to do, I'm going to show you how we can do this with sort of minimal factoring. I'm going to pick an expression to factor, and I'm going to go with this difference of squares. So it's a plus 4, a minus 4. Okay, that's one that I know. Now I know that neither of those factors can be a factor of this, 6, since the last term is a 6. So if there's going to be a cancellation, it's going to happen up here, either a plus 4 or a minus 4. This is a positive. With the middle term being negative, we know that these are both of the form a minus and a minus. So if one of them is a 4, then to get the plus 8, we'll have a 2. Let's FOIL it. A squared minus 4a minus 2a is minus 6a plus 8. Okay, we've got that factored. Now, what else? Well, we've taken care of the a minus 4. How about this a minus 2? Maybe it cancels. If it does, again, we have a plus down here and a minus. This will be a minus 3. A squared minus 3a minus 2a is minus 5a plus 6. Okay, the a minus 2's are going to cancel. How about this a minus 3? Might it cancel with this expression here? Well, if it does, I'm going to get a negative 6. This will have to be a plus 2 and a plus 2. A squared minus 3a plus 2a is minus 1a minus 6. So there we go. We have all the factorizations. At this point, let's pick up the non-permissible values. So what can't a be? It can't be negative 4. It can't be positive 4. It can't be positive 2. It can't be positive 3. So it can't be 2, 3, or plus or minus 4. Okay, so we have 4 non-permissible values. That's any value of a, which in the denominator would make the expression equal to 0, and mean divide by 0, and we're not allowed to do that. Okay, now that we have the non-permissible values, which must be found at this point, we can go through and do some canceling. So what cancels? A minus 3 with a minus 3, right? In both cases, you're left with a 1. These a minus 2's, top and bottom. This a minus 4 with this a minus 4. Leaving me with the expression a plus 2 over a plus 4. Now you notice this expression only has one non-permissible value, which is negative 4, but in order to maintain the integrity of the given expression up here, we need to have our 4 non-permissible values, and then this is our simplified form, and we're simply saying that this expression here is equivalent to this expression for all values of a, with the exception of 2, 3, and plus or minus 4. So that is our simplification, okay, with a lot of factoring, but really we only factored this one, and then we kind of went on a what if to factor the rest. Certainly you could just factor all 4 independently. Again, always making sure, right, a squared minus 3a minus 2a, that you're foiling it out to make sure you've got the right factorization before simplifying. Okay, division, dividing rational expressions. Now, before we do that, let's just remind ourselves, what does that look like if I have 1/3 divided by 1/2? That becomes 1/3 times 2 over 1. We multiply, we don't divide by a rational expression, we multiply by the reciprocal, giving us 2/3. Okay, so same thing's going to apply here. So the first thing I'm going to do is turn this into a multiplication. But there is one thing we'll have to keep track of when we go to find the non-permissible values. Okay, so let's write this out as a multiply. 6x squared plus 7x minus 3 It's just dogs fighting over a bone. Minus 6x squared times, okay, so now we flip this. 2x squared minus 11x plus 5 over 2x squared minus 7x minus 15. Okay, and let's throw an equals out here, because that expression up here is equal to this. Now we're going to go through, we're going to start factoring. So equals, basically we can do sort of the same thing. We can pick one expression to factor. Let's go with these guys. They'll be easier. If you have a leading 2, that's easier to factor. So let's leave ourselves, although actually I can factor this here. This is 3x and 1 minus 2x. This is two terms. It is not a difference of squares, which means all we can do is common factor. I will need 2 sets of brackets up here. And let's expand that out. So what do we want to factor? It's got a plus and a minus. So it'll be 2x and an x. They're both going to be minuses. Minus 1, minus 5. Okay, let's check that. 2x squared minus 10x minus 1 is minus 11x plus 5. Okay, well, there could be a 2x over here as well. So, well, anything? I mean, the x minus 5 could be a factor of that. Let's try it. Let's say x minus 5. I think you're a factor of this, which means to get a 2x squared, I'm going to need a 2 here. 2x. That gives me 2x squared. And to get a 15 and a minus 15, I'll need a plus 3. Let's try this out. 2x squared minus 10x plus 3x is minus 7x minus 15. Ah, nice. That worked. Okay, so the x minus 5, so maybe one of these factors is a 2x plus 3. Let's try that. 2x plus 3. It's plausible, right? Because that's minus 1. So to get a 6x squared, 2x, I'm going to need a 3x. This is a minus, so to get a minus 3, minus 1. Okay, how does that check? 6x squared minus 2x plus 9x will be plus 7x minus 3. Nice, everything's factored. Okay, now let's do our non-permissible values, right? So again, remember what we do, factored form, then non-permissible values, NPV. Where are we going to look? Down here. So x cannot be 0. Let's see, it's, wait a sec now, this is 1 minus 2x, 1 minus 1, so x can't be 1 half, because a half in here. It's negative 3 over 2, so negative 3 halves, positive 5. And are we done? Not quite, because remember, this denominator actually started out as a numerator, and so this is an original denominator, so none of these can be non-permissible values. So this will be a plus 1 half and a 5. They're already taken care of, but very important here, we have to take a look at, I was going to try and change my pen color. Let's see. No, let's try and go gray. We have to take a look at these terms here, these terms here, and these terms here. So anything which I am now circling in gray, those are what we have to watch for our non-permissible values, because they either are in this case, and this case they are in the denominator, or in this case they were in the denominator. All right, now, next step, we can go and we can start canceling out. So I've got a 2x plus 3 and a 2x plus 3. I'm just going to write a 1 underneath to show they cancel. Got an x minus 5 here, cancels with this x minus 5. The 3x and the 3x minus 1, nothing's going to happen there. 1 minus 2x, 2x minus 1. They're pretty similar, but they're not exact. This has a positive 2x and a negative 1, and this has a positive 1 and a negative 2x. So actually there is something we can do to this. So I'm going to come down here. We can go 3x minus 1. I'm going to factor a negative out of this. So I'm going to write this as negative 3x. I'm going to take the negative, so I'm changing the signs here. This will become positive 2x minus 1. So by taking a negative out of this set of brackets, I've changed the sign of the two terms, so it becomes a positive 2x and a negative 1. Times, okay, what's left here? 2x minus 1. Everything else has canceled. Over, let's just put that over 1. And now this cancels with this, leaving me with a 3x minus 1 over negative 3x, and that might also be written as 1 minus 3x over 3x. And these in no way, shape, or form, these three x's, no way do they cancel. As tempting as it is to cross that off and cross that off, they don't cancel. We don't know what x is. If x were 1, then this would be 3 minus 1, which is 2, and this would be negative 3, or negative 2/3. If you tried to cancel these off, you'd end up with like a positive 1 always. So those don't cancel. They have to be factors. Okay, to review, what have we got going on? We're dividing. Okay, we change the divide into a multiply. We factor everything, everywhere. We find non-permissible values based upon things that are in the denominator or were in the denominator. Okay, we use that to state our non-permissible values. And then we cancel, and we look out for opportunities such as this, where I have the same factors, but one requires me to factor a negative 1 out, and then these become the same, exact same, and can be canceled. And so that is multiplying and dividing rational expressions, and you'll have plenty of practice to do to get you good at this, as well as perhaps some more difficult ones which you can ask about in class.